whenever you have the capability of real-time comms, you have a selection of Dpoints that you can receive from the power drive in real time. This list breaks down all of these options into the highest priority. So the most popular Dpoints that you would use, and prioritize them from most essential to least essential at the bottom. If you'll notice how this is broken down, you have your extended protocol Dpoints. So column number 2 is for Schlumberger tools. So if you're running a Maxwell or Slimpulse setup, this is what your tool face display will say. And the next column is for Telepacer. So if you're running Xdirect and that's your tool face setup, that's what the name of these Dpoints will be. So it's good to note that the Dpoints are the exact same name. The only difference is the D&M is _B and the Telepacer is _PD for power drive. Okay, so starting from the top, your most important is your RT stat. So this is a status word, and this is used to show individual values of confirming if your tool is running as expected or if there are some errors or mitigations needed. The value that comes up on your screen, you can input that into your fast downlinking sheet and it'll decode and give you 5 or 6 different messages from one status word. Next is your shock risk. This will come up in values from 0 to 3, 3 being the most severe. Number 3 is INC-B, so this is the real-time inclination measurement of the tool. Next is your POSSUM. It's good to note here that this is your number one indicator of torque jamming. So basically, if it's in a range of -80 to -30%, everything is normal. Any value outside of that range, you're demanding more torque from either your upper or your lower torquer. And this is signifying that you might have torque jamming issues. Number 5 is your steer B. So, for instance, after you send a downlink, the power drive will give you a thumbs up and send up the steer B command, and this is how you confirm that it has accepted your downlink. You use the fast tracking sheet to match the steer B from the corresponding command that you sent. Number 6 is the tool face effective, and number 7 is the desired. So TFDS, that is confirming with the power drive what setting it thinks you're supposed to be in, and then the effective is it grading itself on how well it's hitting that tool face. Same thing goes for 8 and 9. Prop F is the effective proportion. PRDS is the desired proportion. So this is your steering ratio. So the desired, again, confirming what steering setting you have in, and then the effective is it grading itself and saying what percentage it's actually steering at. Number 10 is your ink hold target. So if you're in ink hold or HIA, this is confirming what the inclination the power drive is shooting for. So as you put your nudges in, if they are accepted, this number will reflect that change. Next is your upper torquer RPM. And that's useful for troubleshooting steering issues or for washout detection. So washout detection, if over time at the same flow your value is decreasing, then you might have some wash somewhere above the power drive. Next is your azimuth. This is your real-time azimuth measurement. And the last is your stick slip. So this will be in frequency levels of 0 to 3. And for the RX6, you'll have to calculate this manually in an Excel sheet. So to end this training on Dpoints, I want to leave you with this chart. And we're not going to go through each value, but it'd be good to screenshot this for later reference. Basically, it's all the Dpoints that we just went over, and if you notice, the 4th and 5th column over is the values that will come up for that D-point if there's no communications either with the MWD or between the receiver and the control unit. So this is not to panic, it's just to tell you that you're not getting values. Basically, you're drilling blind. And if real-time comms is all you know, you shouldn't panic here. You just go back to drilling ahead and then surveying to see what the tool did. So that's it for D-points.